for John Huth's proposal oral defense. Um, right now is 9:05 Central time, and today is the 14th of October, 2024. And here with us is me, Dr. Sri Banerjee, Chair, Committee Member, Dr. Zin Tway, and then student John Hugh. So, John, whenever you're ready, you can go ahead and get started.
Yeah, welcome to my presentation on geospatial predictors of diabetes in Central Appalachia. Thank you, Dr. B and Dr. Tway for being here. Again, my name is John Huth. I realize that you guys are probably not completely familiar with me, but I've been a researcher for the Department of Interior and Biological Sciences with the Department of Defense for years. I've done multiple GIS projects and ground truthing, and have degrees that range from everything from macroeconomics and geospatial sciences to medical microbiology and general biology. So I'm kind of all over the board. And this presentation and this whole culmination is kind of culminating exactly from that, all these different experiences. It's my attempt to put them all together. So the background on this is that more than 38 million people have been diagnosed with diabetes. Diabetes is an expensive disease at over $400 billion. And Appalachia itself actually has the wonderful moniker of being in the diabetes belt, which was designated by the CDC. So roughly 16% of West Virginians, a state that is completely encompassed in Appalachia, have diabetes, and many of the disease, many conditions like diabetes, excuse me, I'm sorry, I have a stammer, so you have to excuse me every once in a while, have been associated. There's a lot of things associated with it, a lot of chemical processes, things like that, that actually show up in the geography and in the ecology and ecotones specific to West Virginia and Appalachia. So that before I get started there too, I'd kind of like to talk about where this kind of comes from. It actually comes from me doing some research on fungal pathogens in bat populations. And I was working with somebody from West Virginia, and we were setting up equipment when I found out, to my horror, that his entire family and most of the people that he knows actually were diabetics. So that was kind of a real alarm bell to me. And he said something that has always kind of stuck with me, which was, wouldn't it be great if we could do something about the diabetes situation? And at that time, I was actually doing some geospatial modeling to predict that fungal pathogen. So it kind of got my wheels turning and took me off into a different direction, which is probably a theme in my life. But anyways, gaps in the literature and why it needs to be studied. So diabetes is typically studied via the individual and through social factors, symptoms, diet,
John,
things. Yes.
sorry to interrupt. I'm not able. Are you changing your slides, or are you
I
on the?
I am. Is it not doing it?
No.
Oh, great.
Yeah, there we
It's
go.
okay. It's okay, John. You can just tell us when to flip to the next slide. Not a problem.
Yeah.
I
So
I
I'm
see
now
that.
three. I'm now 3 slides into it.
I
Okay.
see. No, I see the slide now.
Okay. I see it.
Okay. I'm sorry.
All
Um,
right. Mhm.
Yeah, no, I've never done it in this particular program, and this is going to come back and bite me now, right? So, anyways, it's good for comic relief, I guess. So, anyways, diabetes is typically an individual studied disease. There's not a whole lot that's been done looking at kind of a macro environmental sense of what might be contributing to the diabetes epidemic. And so this is my attempt to kind of figure out what those latent macro landscape factors are, and it's just an initial step actually too. And that's something I want to emphasize, is that you know, it's going to be hard to make, you can't make causal inferences from any of these things. There'd be more research probably necessary and ground truthing that would have to happen in order to determine the specific things in those factors that are contributing to diabetes. So diabetes is the 7th leading cause of death in the US. In Appalachia, it's 1.4 times higher than the rest of the United States. And that's exacerbated by high levels of poverty, an aging population, and low educational attainment. And you can actually see that West Virginia, once again, completely inside of it, making it a nice proxy for Central Appalachia. So in Appalachia, there have been multiple studies and governmental interventions that have looked at contaminants that are in soils and actually in the flora of the area. And a lot of what's been found actually is associated with chronic diseases like diabetes, chronic inflammation, obesity, etc. So also Appalachia has limited diabetes screening, limited medical care. Oftentimes hospitals and doctors can be 50, 60 miles away. And currently the strategy for dealing with diabetes in the region is just post-diagnostic care. There's no real strategy, no preventative macro level solutions. So what I'm proposing is to do this quantitative method study where I'll model these different factors and look for collective associations to these dynamic environmental factors, and hopefully be able to suss out a few variables that seem like they could be decent predictors. The variables themselves are the dependent variable, obviously diabetes cases per capita. The independent variables are distance to mine, landfill, impervious surfaces, so all the concrete and everything else. But impervious surfaces actually includes other things like rock faces and scree fields, mean annual precipitation and temperature, and then forest classification. So, and these different variables here are, so all of the distance to variables are considered configuration variables. And then the mean annual precipitation or ratio variable is actually considered a composition variable in GIS structures. All of them will actually end up being different polygons with the point data coming from the diabetes cases per capita, and then a field variable, which is actually considered county median income. And the reason why I'm using that covariate is to possibly suss out and strengthen the model, but I also wanted to try to keep the terms down low so that I don't overfit and just end up modeling noise. Research questions are pretty simple. The first research question is, does the naive model with all of the variables minus median income, is it collectively associated with cases of diabetes in Appalachia? And the second research question is naive model plus the median income, and does it collectively associate with the cases in diabetes? And so hopefully we can see there's a difference there. Hypothesis in this is, again, there's no significant independent and collective association in the naive model, or the alternative to that is that the naive model does have a significant independent collective association. The second hypothesis is similar to the first hypothesis, which is the naive model plus controlling for median income. And then the second alternative to that is that there is an association controlling for income. And so the conceptual theoretical framework for this is pretty simple. It's considered spatial epidemiology, which is interesting. There's a huge gap in spatial epidemiology, but the first person to use this kind of a methodology was actually John Snow when he figured out that wells were an issue for cholera in England. All it does is it really just expands on what we think of as epidemiology by adding a geographical place to it. And it's heavily reliant on using GIS systems. And a GIS is really, you could argue, is anything that is just some kind of a map or plat. So anytime you use your phone or you get directions, that's a type of GIS that's actually being used in that type of technology. The design of the study is it's quantitative, and again, we're looking at collective associations between geospatially dynamic environmental factors and diabetes cases in Central Appalachia. It is a cross-sectional ecological design, and as such, it's great because I can use secondary data, and the downside, of course, being that I'm prone to making the ecological fallacy. So I have to make sure to generalize this to the region or to the state, but not to generalize it to individuals. But it does allow me to determine possible associations between the variables and guide next steps in the whole ground truthing process. Sample size, it's a secondary data set from the US Diabetes Surveillance System, which is part from the CDC. The inclusion criteria of that is West Virginians age 20 plus years and diagnosed with diabetes. All of that will be plotted into actually the GIS software. It's pretty easy. And then I used G-power calculation to determine that a sample size of 103 cases was necessary. All of that those GIS layers will provide me with comma delineated tables, which I'll then read into whatever the newest IBM SPSS is, and perform linear regression so that I can fit a model and see what the relative contributions of all the independent variables are. And maybe, try to keep the variables that really just explain the variation in the dependent variable, the cases of diabetes. ArcGIS obviously is a program I'm going to use. It's a widely used program. I'm going to use that to calculate all of the distances using centroid variables of each county, and all the layers. Some of the layers I could choose 10-meter resolution, but I'm using 30-meter resolution because I'm trying to avoid something called the coastline paradox, which essentially, if you think of each county as having a coast, and that's what its border is, if you change the resolution, it dramatically changes the measurement itself. So the measurements wouldn't be comparable between each other. And so a bunch of issues can actually arise between that. So I'm trying to avoid that and use a little less resolution. And plus, for generalizing, I think it'll work out pretty well. Social change implications. Central Appalachia is rural, to say the least. It is socioeconomically deprived. It is particularly underserved, has high diabetes prevalence and incidence rates. And what I'm hoping to do is gain some sort of new perspective on diabetes to lessen that burden, so that resource allocation might be better used. Environmental mitigation strategies might be used, and we can maybe suggest predictive surveillance, and create kind of a screening hierarchy of where these areas are, if you will, like sort of pseudo hotspots that probably should get more screening and more attention than has historically happened. So in conclusion, wow, I've blown through this really quickly. In conclusion, diabetes is expensive. It seems to be increasing, still at an increasing rate nationally, and it actually it affects everybody. It's kind of a non-discriminate disease. It does affect older people more than younger people. There is some race differences, but it does affect absolutely everybody, and so because of that, it seems like a more comprehensive global approach should be considered. Nobody's really considered environmental factors and what they could do, or what specific geographies might contribute to the disease. And so that's why I'm doing it. And at this point, I'd like to acknowledge both of you, Dr. Banerjee and Dr. Tway. Dr. Tway, I hope I'm saying your name right.
Oh yeah, it's perfect.
Oh, okay, great.
Perfect. I generally just go with Dr. Zinn because it's easier.
Oh, well, I understand that my name is kind of right. It's different, and so it gets butchered. But I was actually nervous about that. So, anyways, I'd really like to thank you both. I'd really like to thank you for all your time and all your effort in what you guys have provided me, and all your guidance. And it's been one heck of a year. And I thank you. Thank you for allowing me to entertain this idea. And with that, I will blow through the references unless anybody really wants to spend time on the references. And
Great, John.
that's what I got.
John, I really commend you for the hurdles you have gone through and going through this presentation. So at this point, I'll let Dr. Zinn provide some comments and questions, and then I'll ask you the questions as well, John.
Sure.
Yeah, John, I was really impressed with presentation. I know you seem a little nervous today, but it's all good, all good. I really do like this study. I think it's very interesting to take a look at environmental factors as they affect chronic diseases. And I'm always interested in the GIS part of it. The one thing I'm having a hard time understanding it's that G power calculation, which is on slide 13. Maybe you can give me some clarity here. For G power calculation, it calculates out the minimum sample size, right? Minimum, not maximum, minimum for the level of data that you're using. And my understanding is you're using data at it's the county level. Is that what?
Yeah.
Okay, but it's 103 cases per county. That part I didn't understand that actually.
Okay.
How does 103 cases? Are you excluding counties that have less than 103 cases of diabetes, or is
there are none?
Okay.
There are none. So that wasn't an issue. In fact, if you look at it, there's this concept in ecology called occupancy.
Mm-hmm.
And so since the rates are so high in each of the different counties,
Mm-hmm.
It qualifies as occupant. In other words, there isn't a chance that you're not going to find the disease.
Okay.
So typically, a lot of these types of studies would actually be performed as a logistic regression.
Right.
And so in disease ecology terms, we would actually look at presence, probable absence.
Mm-hmm.
So we're not doing that here because that doesn't make sense. It's different. And again, it's different for wildlife populations than it is obviously for humans. But when you have occupancy, then you can look at a particular region and know that's actually the case. And then those cases that are identified per area actually represent that area. And so you need to have a minimum number for what occupancy would actually be. And so I think that that's what the 103 is. Can you believe I can't actually find it in my slides here? But
It's on
so
slide 13.
yeah, I got it now. That's
Okay.
where that 103 is. And so in other words, it would
I
have
got
to
you.
have a minimum of 103 in that area. And there's no chance that it doesn't have 103.
Oh, okay. So it's regarding occupancy, not the actual level of data that you're using.
Correct.
Got it. Okay, that's where, because the way that it's written in terms of normal, like,
Yeah.
so
No, it's right, because nothing that I'm doing is normal.
No. It's okay. It's perfectly okay. But I think that it might be of value to make that clarification when this goes to IRB.
Okay.
Because if I'm confused right now,
yeah.
IRB, and John, you probably know this already, every mistake you make is a 2-week penalty.
Yeah.
And we want to avoid those 2-week penalties.
So you guys are efficient. If I made a mistake at the government level, it's 3 months of me sitting there twiddling my thumbs. So you guys are efficient. I'm sorry, sarcasm.
Yeah, we just want to get rid of you. That's our goal.
Wait, my wife says the same thing. Wait a minute now.
She's failing at it.
Yeah, I know. 35 years of failure.
Yeah. But anyway, that was the only, I think this is great. So I'm going to turn this over to
well, I'll try to rework that in the document, and I maybe expect to see it a few times. It's been really one of the things that's been tough for me is a lot of this stuff is like a doy, because this is what I do on a regular basis for a lot of different things. But then when you come to try to explain it, it becomes difficult because what's my common knowledge is not necessarily the common knowledge. And so sometimes I have struggled with that. Dr. Banerjee can tell you, I've struggled with that every step of the way. And it's like, oh no.
So, one thing that you could approach this with, because I'm thinking IRB in terms.
Yeah.
If you put in, if you identify the 103 cases per county qualifies the county to be in the study.
Okay.
Right?
Yeah.
That covers that part of it. And then in terms of the G-power calculations, because how many predictors do you have? Was it like 5 or 6 or something like that?
Yeah, that's exactly
something like that. So that gets you into a minimum sample size actually around, it's in the high 80s. But not to worry, because I know there's only 55 counties. But what you can actually make that statement is that once completed, a post hoc sensitivity will be connected, right? So that way you can calculate out post hoc, because you only have 55 counties you're working with. Right. So that way it covers all the bases, and that way IRB won't kick this back.
Okay.
So
that's all. I'll add that. That's great. I appreciate it.
All right. So Dr. Zinn, thank you for those comments and insightful ideas. So in terms of John, some of the things, and we've kind of talked about this, all right, so underdiagnosed diabetes, right? Or undiagnosed diabetes. Do you think that the rate of that is higher because screening is so much lower, and how does that affect your findings?
Yes. So the actual presence of the actual occupancy numbers of diabetes in each of these counties is I feel safe saying it's considerably higher than what's actually reported. The lack of medical care, the lack of screening, and how do I put this delicately? The Appalachian non-trusting persona, they just don't, means that there's a lot of people showing the symptoms that aren't being diagnosed until death in a lot of instances. And they just won't go. They won't actually seek these services. Services oftentimes include things like medical bus, which actually goes to different counties. But even though it's complete, like there's huge lines to do things, Most people avoid that because they're afraid of what the, and I quote, the government will do.
Mm-hmm.
They
Mm-hmm.
they find they're really concerned that this is somehow some sort of government agency conspiracy thing that's actually happening.
Mm-hmm.
So yeah, I really do think that those numbers are well underreported.
Mm-hmm. All right. All right. No, that's a great answer. So I had a question, and these are more content related. And right. In terms of the diabetes belt, you were explaining that, and I've classically known, and this is what I learned in medical school, is that the diabetes belt was only the South.
Yeah,
So
yeah.
what is the South compared to the Appalachia? What makes Appalachia more vulnerable compared to the South? I mean,
Mm.
the culture is different. So
Yeah,
what are some of the facets that? Mhm. Go ahead.
it's culturally different, but it's
Mhm.
geographically different. So typical of, and I say typical again,
Mhm.
not all of Appalachia.
Mhm.
For example, portions of Pennsylvania and New York have
Mhm.
a different geology,
Mhm.
but they're all kind of karst-based geology,
Mhm.
and so the rock types are similar, the soil types are similar and minimal
Mhm.
and poor. And as a result of that, you don't get the ecosystem services that you normally
Mhm.
get from other 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 areas.
Mhm.
So, for example, if you looked at um, Louisiana and you looked at their swamps, that's a
Mhm.
riparian forest. Riparian forests are particularly good at upcycling and recycling things so
Mhm.
that that plant life actually freshens those water types. And so if you look at spectral aerial imagery of those things, you'll see that they actually fluoresce in a different color
Mhm.
that's consistent with things like arsenic and lead.
Mhm.
And so you can actually see those forests working with the right satellite, with if Landsat is actually working. If you look at Appalachia, you actually
Right.
end up getting mostly kind of poor soils, coniferous forests, a
Mhm.
lot of spruce and Norwegian spruce.
Mhm.
So acidic type things. Again, um, they don't have the traditional soil structure, which is a 7 soil structure. They have
Mhm.
traditionally in most places, based on soil services that, the soil conservation services, they
Mhm.
typically only have 3. So
Mhm.
again, everything coming down and trickling into your water supply
Mhm.
and all the things that you're growing, it's not quite as well refreshed.
Mhm.
It doesn't get scraped off of it, and so that's what makes that region kind of different.
Mhm.
Also, the landform index is okay. So landform
Mhm.
index is is kind of this kind of culmination score of what the mountains do, what the
Mhm.
valleys look like, and so it
Mhm.
gives you a kind of a concept of what the hydrology of the area is
Mhm.
and what the mountainous type region is.
Right.
It's very different than any other region. Period.
Mhm.
So like, and especially like, obviously you can come here and you can look at, the mountains and then you compare it to the Rockies
Right.
and everybody goes, oh, that's nothing. But the
Mhm.
valleys themselves are
Mhm.
they're peculiar.
Mhm.
And so you'll see that in the scores, in those landform index scores, it's just very different. The hydrology is really strange. That's actually one of the things that compounded the Hurricane Helene stuff in North Carolina
Oh, that's a
is
whole
that
nother.
landform index. It's
Mhm.
the way that water was going to go. If landform index had been used in building code, a lot of the destruction that happened would not have happened. They would have been
Mhm.
should have been ready for that. But you can get away with that in other areas because
Mhm.
again, it's the way things are flowing. And when I
Mhm.
say flowing, it's not just water; it's soil flows too, and
Mhm.
rock flows too, and
Mhm.
so
That's
does that
no,
does
that's
that
that. you know, in many of my conversations with you, some of the areas that I've really learned is about how the environmental variables can relate to disease conditions, and that's something unique and different, and I can't wait to see the findings.
Yeah.
So
The
I
interesting
think
thing
some,
too is that the
yeah.
flip side of that is that some of the answers might be in those environmental answers. For
Mhm,
example, we do a really poor job of maintaining riparian forests on the East Coast.
mhm,
If you did that, you get a couple things. You get a
mhm,
cooling effect, which
mhm,
that might be kind of nice right now,
mhm,
and you actually get uptake of a lot of these potentially dangerous substances.
mhm, mhm.
Um,
All right, all right. Well, I think you told us about your comfort level with using ArcGIS. Of course, a lot of things will rely on that. And so,
yeah.
again, I'm looking forward to exploring that. All right. So, yeah.
What could go wrong?
Right, what could go wrong? All right. So,
It's
Dr.
just
Tupet.
technology. What could go wrong?
Right. All right. Dr. Zinn, so do you want to kind of come to a common consensus to be able to see where we stand?
Oh, absolutely. I think that
Mhm,
I think we should move John forward to the next
mhm,
steps.
mhm, mhm. All right, so I concur with Dr. Zinn. I think you're ready, more than ready. So congratulations
Yeah.
on
Yeah, yeah.
reaching this significant milestone.
I
We
feel like
all
I'm
have been
saying,
waiting.
"Put me in, coach."
And you'll be in the same league as Renee, as Dr. Huth. Um,
No, no, I will never be in that league.
yeah, Dr. Zinn, John has his wife actually already has her diploma, and so she's urging him to complete his. So,
Yeah,
Excellent.
yeah,
mhm,
yeah.
Excellent. Yeah, of course he'll never be an equal, but he will
No,
have
no,
it.
no, no,
As we all know.
no. Yeah, no. I'm never the equal, but
Fantastic.
somehow I end up doing a lot of R for her, or
Excellent. Okay.
and I'm like, I don't think this is how marriage works, but okay, sure, I'm happy with it.
Fantastic. Okay.
So
Great.
All
thank you,
right.
thank you guys. I really do appreciate
Yeah.
it, and I'll
Yeah.
make those changes. If I stumble a little bit, I'll reach out to
Yeah.
and now
Yeah.
to
Mhm.
get this to you. Next steps. It's all. Is it all
Right.
through
Right.
text read? Or,
Right. So let me go through that. So I'll go ahead and approve if that's all right with Dr. Tway, and then
Yeah.
afterwards we can kind of incorporate that as you're writing your final paper. So
okay.
we can kind of work with that.
Yeah.
Is that you think
I think
a good game plan?
you've got to do something for the IRB application. It just,
Right. Right.
yeah.
Right. The
So, but
formatting.
it shouldn't be very much. It's only going to be like a paragraph. That's all you're
Mhm,
really altering, right? The minimum
Yeah.
number of
mhm,
cases per county is 103, and then you can reference that however you want, and then just say using G power calculations, the minimum sample size is this,
Okay.
mhm.
right?
Yeah,
Or if you
that
want,
should be
you can
straightforward.
adjust
I
the
think.
effect size,
Mhm.
adjust the effect size so you get to your 55.
Okay.
All
Yeah.
right, let's do that. Mhm.
Yeah, that'll work. And I can send you because yeah, all you have to do is just adjust the effect size. That's all it is. And until you
Okay.
get to 55 and you'll be fine.
Sure.
Mhm.
Sure. Okay.
All right, so yeah, again, Dr. Zinn, thank you for
Mhm.
your guidance and the methodology. And I think we have a great team together. And I think moving forward, I'm again looking forward to the final
Yeah.
findings for this. So, mhm.
Yeah. And John, if you need any help with FPSS, just feel free, reach out to me. I
Okay.
can help you. I use it all the time. So
Yeah. No,
Yeah, he did.
I don't. I was a SAS guy before this,
oh,
so
okay.
There's a
you
lot
know
of
what I mean. It's
tutorials
like
out there. Mhm, mhm,
it's oftentimes Greek to me, and there's oftentimes tears and some temper tantrums, but usually I get there, right. I
Yeah.
hit the curb a couple times, but I'll get it down the road. But yeah, I'll
mhm,
definitely reach out to you. I
Yeah.
suspect
I mean,
you'll hear more
mhm,
from
if
me.
it's
mhm,
because there's no point in you struggling. So if
Right.
you put for me, if you want to put everything onto an Excel spreadsheet,
Yeah.
okay, where you've got counties in terms of rows that are horizontal and then all your factors
Yeah.
above in the columns.
Yeah.
That's the easiest. No, just raw data only, no summary data.
Okay.
That's it. And then from there we
Okay.
just import it in, and then we just walk through it, and it's easy. We can just, it won't take but maybe like an hour.
Yeah. So that's essentially what you would do, importing the stuff over from R. So
Yeah,
that's great.
same idea. And if your data's in R or even in SAS, it can be imported into SPSS directly. So
Okay. Well, I wonder if Esri's data can. It might be. I've never. Again, I've
It
never
can.
done it.
It
Yeah.
can.
Can it?
yeah.
Yeah. So
It-
that might be the
Mhm.
solution, because I know they have
You
a
can-
model builder themselves,
Mhm.
but the statistical outputs,
Right.
they're
No,
not
that should be
quite as in
straightforward,
depth. Yeah.
because then you can convert to Excel in a toolbox. That's one of the toolbox features in ArcGIS, ArcMap.
Isn't that great? I didn't know that.
Yeah,
So,
yeah.
fantastic.
Mhm.
I've only been doing this since the 90s.
All right.
Well, all
All
that
right.
time. Thank you very
Sounds good.
much.
All right.
I appreciate it.
Congratulations, John. Thanks
Thank
so
you.
much
Yeah,
for a great
well,
presentation. It's
great
great
seeing you,
talking with
Dr.
you.
Zinn.
No, it's always good seeing you. So,
Yeah.
all right.
Mhm.
You
Thanks.
guys have a great Monday.
You too.
Yeah, you as well.
Bye.
You as well.
Bye-bye.
Bye.